All right, it's recording. Hello, guys. Um, Welcome to Lab 2. Today we're going to be talking about body composition. This one was fun in person. I would have you guys make sure to wear like bathing suits. We'd be like stepping into a hydrostatic weighing tank, which we had cleaned, and despite cleaning, sometimes it was still a little gross depending on what lab section you're in, because we would clean it in the beginning of the semester, and we wouldn't clean it between lab sections. We'd just drain the water and refill it back up. um, and like that scene in Tarzan when the elephant's just like, are you sure this is sanitary? Yeah, that's like basically me, uh, when we would have this lab, but um, we did our best. So also sorry, there's a bright light right here. I'm not filming this in the evening, so sorry about that. But anyway, today we're talking about body composition. We're going to go through this pretty quickly. We're going to go through introduction, what is it, how to determine body fat percentage. We'll talk about the methods, so like the experiments that we're going to do. And then no purpose statement hypothesis. You guys can watch your methods videos, and then really briefly going over the results. We have a little John Cena at the top. Very nice, very, very nice. Okay, so body comp overview. It's just proportion of fat mass to fat-free mass. So you're fat, not fat. There's a couple compartment models that we're going to be using that we're talking about. So we have our 2 compartment models and our 3 compartment model. Two compartment is just fat mass and fat-free mass, so differentiating between the 2, and 3 compartment is fat mass, fat-free mass, and bone mass. Fat mass, so it is divided up into 2 categories, essential fat and non-essential fat. Essential fat is fat located within like organ systems, so within your bone marrow, within your central nervous system, heart, liver, lungs, muscles, joints, things like that. This is essential, like the name, for normal physiologic function. So if you don't have it, you're gonna not have normal physiologic function, and you should probably find it somewhere. But for men, you usually have 3 to 5% of your fat is this, and then for female, 10 to 13%. This is the difference is because, estrogen, lots of estrogen and not as much estrogen. Females need to be able to bear babies even if they want to or they don't want to. We don't really have a choice in the matter. But yeah, this is just what is required. So non-essential is everything else, all the other fats. So your subcutaneous fat and your visceral fat. This is the storage fat. The subcutaneous fat is exactly what it sounds like, under cutaneous skin. So under your skin, it's gonna be the stuff that you pinch, and then your visceral fat, I don't know if you've seen like those older men that have those like big beer bellies, but when you like touch them, they're hard. Yeah, like they're like, oh, why is your fat hard? It's because it's underneath the muscle. So what you're touching right there is the muscle, which is the hard part, and then underneath that is a fat. So this fat is not good. This is like the kind of worse fat for you. This is associated with things like heart disease and type 2 diabetes. So no bueno, no good. Body density. So we have your fat-free mass, which is muscles, bones, connective tissue, organs, fluids, things like that. Your lean body mass is your fat-free mass plus your essential fat. So everything that's like super, super important. And then you have your bone mass, which is bone mineral density. So minerals stored within your bones. Easy. Calcium, phosphorus, magnesium. So how do we calculate body fat percentage? It's like, how do you do that without using, ADEXA and like crazy technological stuff? Basically, we find your body density. Muscle, we know that muscle is denser than fat. So, um, 1.1 grams per centimeters cubed and for muscle, and fat is zero point 0.9 grams per. Oh my gosh, I literally just blanked on English and I just said the word centimeters cubed. Anyway, so essentially what that means is more fat-free mass means higher body density, which means a lower body fat percentage. And we'll use this, like you'll use equations to do this calculation. You'll see. It seems like a lot and complicated right now, but it's really not. It's just plug and chug. You get the numbers, you put them into the equations, you do your calculations. Really easy. I'm going to talk about different modes of measuring body composition. So we have a bunch of really common ones right here: BMI, waist to hip, skin fold, hydrostatic weighing, DEXA, bioelectrical impedance, and BOD-POD. I think I'm going to talk about all of those except for waist to hip, but they are all very useful in different contexts. Body mass index. So recently, like in the, I guess, health world, it's been kind of demonized and it's like, oh, BMI is not like accurate for people. That is true, but not accurate for certain populations. It is accurate for the general population, so general overall people, it is accurate, but for certain specific populations, not as accurate. So BMI, what is it? Body mass index. Basically, it's just your weight over your height squared. And that's it. And you get this magical number that we can classify into different categories. So right here you can see underweight, healthy weight, overweight, obese, and morbid obesity. And you have your numbers right here. So pros, it's super cheap and easy. Like all you have to do is measure your height and weight. That's it. You don't need like any kind of specific tools or like qualifications or like training or anything like that. You can do it at home. You don't need like a professional to do it either. Cons, it's not appropriate for all populations, like I said before. It's not appropriate for children or for athletes. Technically, you can find BMIs for children using the CDC growth charts, but that growth chart is different from this kind of chart. So you have to like use that if you're going to use BMI for children. Otherwise, yeah. But the reason why it's not appropriate for athletes is because athletes tend to have a higher uh, muscle quantity within their body. So it'll say that like a powerlifting athlete is like morbidly obese, or like a bodybuilder is morbidly obese, but they're not. They just have a lot of muscle. So it doesn't take into account the difference between muscle weight and fat weight. But the general population does not have an extreme amount of muscle. So for the general population, this is still a good method of uh, body composition, basically. Bioelectrical impedance. So this is also something that isn't required for like training or anything like that. You don't need to have special training. You do need a special kind of scale. This could be like the hand and foot scale, or just the hand, or just, the regular foot scale. So basically what it does is it sends a weak electrical current through your body, and then the time it takes to get back to the equipment, to the plates, that's basically how it's going to, the time is going to, how it's going to use like calculations or whatever to predict your body fat percentage and muscle percentage, whatever. The reason why this is like not a super great tool to use is because a lot of things can be like influencing the outcome of this. So what this tool is used for, what it's great to be used for, is like day-to-day or week-to-week changes. So if you are using this to find change in body fat percentage, yeah, this could be used for that, as long as you're using it in the same method every time you measure yourself. So first thing you do when you wake up after you, like, you know, take your morning number 2 and pee or whatever, you'll get on the scale, you'll measure your body fat percentage, you'll measure your weight, and then you'll do that in the same way every single morning. That's a good way to use this machine. A bad way to use this machine is to just step on it one day and like look at your body fat percentage and it's just like, yep, that's what my body fat percentage is. It might not be like totally accurate, because depending on your hydration status and a bunch of other factors, it's probably not gonna be like super accurate. The one time body fat percentage, that's not gonna be accurate. But it's cheap and easy, no experience is required. And yeah. Skinfold. So Skinfold is a really good way of measuring body fat percentage, but you have to kind of be trained. So the only way it can be really accurate is if someone has experience doing Skinfold. So if an experienced tester is taking your Skinfold, it is most likely going to be like fairly accurate. But like I said, you need someone who has experience doing it. So it's easy and cheap, and it can be super accurate, but you need an experienced tester. And basically what Skinfold does is you have to calculate body density, and using body density in the Skinfold measurements, then you can figure out body fat percentage, fat-free mass, fat mass, things like that. Hydrostatic weighing uses the same kind of equations that Skinfold uses. Skinfold bases its equations off of hydrostatic weighing. So that's really cool. It's cool for us because we don't have to use like a billion different equations in this experiment. So we can use pretty much the same equations for both of these experiments. This is also a 2-compartment model, fat mass. You're determining the difference between the fat mass and the fat-free mass. Based off of Archimedes' principle, it's basically, it measures water displacement. So how much water, or like how much room do you take up, basically, is what this measures, measuring volume. It is the gold standard of determining body fat percentage, which I don't know about that, because like DEXA is pretty sweet, so I feel like that would be considered the gold standard. I feel like DEXA is, depending on the hydrostatic weighing tank being used and how accurate the machine is, I feel like that might be not as accurate as DEXA, but it is considered the gold standard. But there's some errors that come with it. So residual volume that's left within your lungs, it doesn't account for that. Farts. So all the gases that are like stuck in your intestines, it doesn't account for that kind of volume. And density of lean muscle tissue may differ in certain populations. It's also kind of expensive. You need like a whole freaking tank full of water and cleaning and solution and things like that. You need people to clean it and do whatever, do maintenance with it. So yeah, it's not super cheap. Like I said before, DEXA. DEXA is a X-ray basically. So it's a full body X-ray, and it measures like bone mineral density. It measures your fat mass, your fat-free mass. So this means it's a 3-compartment model. It provides a lot of really accurate information. And it's quick, non-invasive. You don't have to pinch anyone's skin. You don't have to have them like undress or anything like that. But it's super expensive, and a lot of times you need like special permissions to use it or specialized people to use this thing. So like when I was doing my undergrad in West Virginia, we had a DEXA, but we weren't allowed to touch it because we needed a radiologist to press the button. So we never got to use the DEXA, which kind of sucks. But because certain policies, whatever, you needed to be a radiologist to use the DEXA. BOD-POD, it does very similar things to hydrostatic weighing. It's just displacement of air instead of displacement of water, measures your volume basically, blah, blah, blah. I really like the BOD-POD because it looks kind of funny when people are like sitting in them, just like, they look like they're in little like spaceships. It's kind of cool. All right, so basically we're doing 2 experiments, we're watching 2 experiments basically. Skin folds, what you do is you locate a certain part on the body, certain like 7 for our case, 7 areas on the body. I believe it is chest, mid-ax, abdominal, suprailiac, subscapular, sorry, subscapular, thigh, and triceps. I believe that's all of them. I might be missing one. But basically, you locate all of those locations, you mark it with an X, and then you go in like a rotation. So you start off with chest, you measure the chest, and then you go to like triceps, you'll measure the triceps, and then you'll go to subscap, you'll measure the subscap, and then you keep going down through your list, and then you start over again when you do trial 2. So trial 2, you'll start with chest, and then triceps, subscap, everything like that. It's in a rotation. And be sure not to measure the same like site twice in a row, because if you pinch the same site twice in a row, then you'll get not as accurate information, because when you pinch, like water displaces and like you have to like make sure everything goes back to normal. So yeah, so when you pinch your site, you pinch it like that, you take your calipers and then you put it on the little pinch site and you read them. You read how many millimeters it is, you write it down, and you go on to the next site. Super easy. Hydrostatic weighing, basically you have to first find their vital capacity, because this needs to be put into the calculations. You need to like calculate you need to basically account for the volume in their lungs. Then you measure their body weight, have them step into the tank. They'll pat down their clothing to remove any air bubbles. And then we'll tear the scale, make the scale 0, have the subject step onto the chair. It looks like a perch to me. It looks like they're like a little bird, and they're just like sitting on the chair. You'll have them exhale fully, as much air as they can get out of their lungs as they can. Then they'll submerge their head, and then wait for the leader to get the number down, their weight, and then they'll knock on the tank. They'll have them come back up. And sometimes it sucks because you have to do it 5 times for some people, because the numbers are off, depending on how much they exhale, if they're wiggling, things like that. Repeat for a minimum of 3 times, or until 2 values are pretty close together, within like 0.25 kilograms. Watch your videos. This is the subject's information, so you'll need this to answer discussion questions and to do calculations, things like that. These are the calculations. They're on your lab manual, so you don't really need me to go over them. If you have any questions about them, please ask me. These are the reference values. And then, yeah, we're done. Thank you. I'll see you guys soon.